Today in this video, we are going to talk about finding a magnetic induction on the equatorial line of a bar magnet. So, first I will tell you what do you mean by equatorial line of a bar magnet. Then we will go for the derivation. Let us see. This is what do you mean by a bar magnet, which is in the shape of a bar. As you know, every magnet has two poles. One is a north pole, another one is a south pole. Each pole have the same pole strength of M, but their nature is different. One is north, another one is south. Between the poles, there is a certain length that is called magnetic length or length of the magnet. This could be treated as the center of the magnet. From center to one pole L, another pole L, together it is 2L. Then, what do you mean by an axial line is line passing through magnetic center and through the poles is called as an axial line. So, this line is an axial line. And what is an equatorial line is? Line passing to the center of the bar magnet and perpendicular to axial line. As I said, this is an axial line. Thus, this line, which is perpendicular to axial line, is an equatorial line. On this equatorial line, we want to find a magnetic induction. What is magnetic induction? It is the force experienced by a unit north pole when placed in a magnetic field. So, at this place, we is somewhere at a distance d from the center of the magnet. Let us keep a unit north pole. This unit north pole, because of the north and south poles of the bar magnet, experience a resultant force, and that's called magnetic induction. So let's find out the forces acting. Yes, on this unit north pole of the bar magnet plays a repulsive force because they are similar poles. Similar poles repel each other. So what's the direction of that force? Along the line joining of these two lines. So this is the force F. How much is that force is? I can write. As this distance is L, this distance is D. This distance, as per the Pythagoras law, becomes root of D square plus L square. So the force between this and this pole, using the inverse square law, is mu0 by 4 pi. M1 is M. M2 is a unit north pole by distance square. Distance is square root of b square plus L square whole square. That's force due to the north pole. Parallel on this unit north pole, due to this south pole also is a force. But that's the force of attraction because this is the south pole and this is the north pole. Between the opposite poles, there's the force of attraction. So what's the direction of that force? This is the direction of that force. F due to the south pole. The upper one is F due to the north pole. And if you notice, the distance between these two poles is also the same because this is L and this is D. The distance becomes root of D square plus L square. The poles are also same. So everything is same, but the direction is different. So Fn is equal to Fs in magnitude, but in direction they are different. There are two equal forces having certain angle between them. How much is that angle? That's an exterior angle to this interior angles. So let this angle is theta, this angle is theta. So the total angle becomes exterior angle is the sum of the two interior angles, 2 theta. So there are two forces, force north and force south, having an angle 2 theta between them. And the resultant force is, we have already discussed this using parallelogram law so many times. F resultant is when the forces are equal having a certain angle, the value is F cos whatever the angle between the two forces by 2. Right? Sorry, that is 2F cos theta by 2. That's the trigonometry formula. Two forces, the angle theta using parallelogram law, you can get this formula. Right? You know this. You can check parallelogram law. And we can write an equation. In fact, I can write an equation if you want. Yeah, I'll write it. F resultant could be written as root of F square plus F square 2f cos theta. Assuming theta is the angle between them. General formula I am writing. So this will be square root of 2f square, and 2f square is common, 1 plus cos theta. So square root of 2f square, 1 plus cos theta is 2 cos square theta by 2. So under square root it is 4f square cos square theta by 2. So the resultant will be 2f cos theta by 2. That's what I have written. But be careful, theta is the angle between the two vectors. In this case, angle between the two vectors is 2 theta. Be careful about that. So resultant will be 2f cos, angle between the two forces is 2 theta by 2. So your answer will be 2f cos theta. What's the value of that theta? I can write that theta now. Look here. This is the right angle triangle. Cos theta can be written as, for this theta, this will be adjacent side L, by this will be the hypothesis. Root of d square plus L square, that is cos theta. I know f, I know cos theta, so I can substitute in this formula. How much is my answer is 2. What is f? Mu naught by 4 pi m root of d square plus L square whole square. This value f, and cos theta. What is cos theta? As we have just now proved, this is the value L by root of d square plus L square. Yeah, cos theta is L by square root of d square plus L square. Let us simplify this further. M by 4 pi. Small m into 2m is called magnetic moment. Capital M, we know that. Root of d square plus L square whole square is there, therefore square and root will go. And square root of d square plus L square. So how do I simplify this? This is mu naught by 4 pi m d square plus L square. This is whole power of 1. D square plus L square, square root means whole power of half. As the bases are same, the powers can be added. 1 plus 1 by 2 is 3 by 2. So what's my final answer is? Resultant force on the unit north pole placed on the equatorial line is mu naught by 4 pi m by d square plus L square whole power 3 by 2. That's the answer. That's the derivation. What if your magnet is a short bar magnet? If magnet is short, its length is much smaller than that of the distance where you are calculating equatorial line. Then L square becomes much smaller than the d square, this L square. I can ignore that in that case. So what happens in that case? Magnetic induction becomes mu naught by 4 pi m by, ignoring L square, d square whole power of 3 by 2, square and square will cancel. So the value on equatorial line is mu naught by 4 pi m by d cube. That's an expression for the magnetic induction on the equatorial line. I want to tell you just that in the previous equation I have derived magnetic induction on the axial line. For a short magnet, its value is mu naught by 4 pi 2m by d cube. Just refer the previous video. But equatorial line, that 2 is missing here. There is a 2 extra here. Yeah. So what we can say, how is the relation between them? The axial line is mu naught by 4 pi m by d cube, that is of equatorial line, and 2, this 2 is there extra. So what we can write is the axial line is 2 times of the equatorial line. So magnetic induction on axial line is more when compared with the equatorial line. That's the understanding. Thank you for watching.